Welcome to the Geopolymer Camp. This is the second of a series that I hope will last forever. We want to organize every year a Geopolymer Camp at this institution, the Institut Universitaire de Technologie in Saint-Quentin. I will present every year, as long as I can, what I call the state of the geopolymer research and development, equivalent to the famous state of the nation. It is here the states of the geopolymer research and development. And this state of the geopolymer research and development will in fact focus on what is happening on the internet. You know that now everything is happening on the internet, and I have taken some events that generated a lot of noise, a lot of buzz on the internet. We have geopolymer science, geopolymer technologies, geopolymer cement and concrete, and geopolymer and archaeology. Let us start with geopolymer science. I want to show you the evolution of geopolymer science, and for that I have plotted on the map what is happening since 1999. 1999 on the map represents the participants at our second international conference on geopolymer that also was located in Saint-Quentin. And then you have 2005. The number of research institutions in the world is increasing, as you see. 2008, we have a shift to the eastern region, Southeast Asia, and this is what is happening in 2010. So you see that the number of institutions in the world is increasing exponentially, and in fact, this will have a consequence on the amount of scientific papers that are published each year. And I will plot here what we get when we just use one keyword, the keyword geopolymer, in the famous database SpringerLink and Science Direct. We have here, starting in 1991. 1991 is the date of the publication of one of my papers that is taken as the reference, published in Journal of Thermal Analysis. And you see that from 1991 until 1997, it is level with 1 or 2 or 3 publications per year, which represent the amount of papers that have been written by myself and some of my colleagues in the USA and elsewhere also. Then in 1997 I met for the first time one representative of the Melbourne group in Australia, and from there they started the research, and it increases up to 2002 when we have another gap, and then an exponential increase of publications. We don't forget that in between we had also our geopolymer conferences, Geopolymer 1999 with 32 presentations, Geopolymer 2002 with 42 presentations, and Geopolymer 2005 with 61 presentations. But the exponential increase is also partly due to the input of our Chinese colleagues, where you see that from 2003 to 2006 very few, and then from 2007 upwards very fast exponential increase. So it shows that it is now time to reorganize the system, maybe on the field of paper publication, but also in the fields of geopolymer conferences. We have geopolymer conferences And I'm starting to organize the systems. I'm not against conferences that are organized locally, regionally, in order to gather scientists or engineers working in a very precise geographical area, but I don't like the presentations of international conferences that are starting on the themes of geopolymer just because geopolymer is something that is good to have on the title. And we have decided with Professor Craven in 2009 to try to focus on 2 official geopolymer conferences. We want to organize something that is really reflect the good science and good applications. And we decided to have 2 events every year. The first one located in the US in January at Daytona Beach. This is the Geopolymer Symposium within the frame of the International Conference on Advanced Ceramic and Composites. This is organized by the American Ceramic Society. This is a regular conference for scientists. So those who want to have their paper published in the proceeding, this is where they have to go. And the second in Europe in July, this is the Geopolymer Camp. And in between, of course, we may have locally regional conferences. For this year, I've been asked to organize something very important in India, because India, like China, is the country where geopolymer is something very important for some vital applications. And we will have a very important workshop in the south of India with Professor Rangan from Curtin University in Perth, where I will present geopolymer cement and geopolymer concrete and also the others. And Professor Craven asked me to have officially to support next year a conference in Australia that will be the PAC Rim. That's the Pacific Rim. These are the gathering of the ceramists that are working around the Pacific Ocean. These are some very special conferences. As for the book, Geopolymer Chemistry and Applications, before the end of the year, we will have sold 500 exemplars, which is something very interesting in terms of numbers. We'll get our first Chinese translation. The 500 is not enough for them. The publisher target is 3,500 for the first 3 years. And I will prepare my 3rd edition for next year. The Geopolymer Chemistry and Applications will be a book that will reflect the progress in the science. Today it is 1 volume. Maybe in 5 years or 10 years from now it will be 2 or 3 or 5 volumes. We will see how often we have to add a new edition, depending on the importance of the work that had to be added in the system. So I will now share with you some particular events that essentially happened on the internet. You know that now news are always buzzing. These are the buzz on the internet. And what is happening on the internet in terms of geopolymer science in 2009 and 2010. The American Ceramic Society discovered the geopolymer science thanks to Trudy Criven, and in March and April they put some of our small videos and access to all the members of the American Ceramic Society, and they put also a special video interview from Professor Criven. So this is a very powerful organization that is endorsing officially the development of geopolymer science and technology. Something are also moving in France. Everybody is asking me, what is happening in France? Since you are living in France, usually big major science should be here. It wasn't. It wasn't until, still recently, last year, something happened at our national parliament. There are commissions, and there are people, parliament members, that are in charge of focusing the strategy for future scientific development. And in March 2009, they published a report. This is in French the Office Parlementaire. This is the Parliamentary Office of Evaluation of Scientific Choice and Technology. And within the framework of research that has to be undertaken with the field of energy, they published a report. And in this report, they cited the geopolymers, and they made recommendations. Two vital: develop geopolymer chemistry and develop photovoltaic plastics. So we are the same level. Geopolymer science is as high-tech as photovoltaic from the French member of parliament point of view. And I hope that within 10 years we will have here on this campus our first geopolymer research center officially taken by the French universities and government. So, second point, geopolymer technology. Oh yes, things are important. Industry is also interested in supplying the materials for geopolymers. We had one supplier that was Imerys. Former name was the China Clay, and this is the famous metakaolin Metastars that I started also with. But there is a second one. In fact, this is a French company, AGS, that I really started with in 1972. And they helped me to develop the geopolymer chemistry because they had at that time the first metakaolin that really worked. And now they resumed the manufacture of this type of material, and this is what they have developed, and they are at your disposal for supply. And second good news, supply of blast furnace slag. For me, we have two major important ingredients, and blast furnace slag is a very geopolymeric ingredient in terms of chemistry. We had a problem in Europe. The blast furnace slag has been practically not available because it had been kidnapped by the Portland cement companies. Apart from one supplier in the United Kingdom that is now part of a cement company, and apart from one supplier in the Czech Republic, it is impossible to get slag in Europe. So now one of the major steel manufacturers in the world, ArcelorMittal, France, has decided no longer to cope with the cement company, but to freeze the sale of blast furnace slag. I had a meeting with ArcelorMittal in April this year in France, and their subsidiary company is located in the east of France, in Lorraine, and they are now ready to supply any thousands and thousands of tons of slag that is wished. Of course, today the market is the additive to Portland cement. But this is also good news because it's opened the free development of mass applications. Since 1999, Australia started to be very interested in the geopolymer science and technologies, and they are organized in several groups, and this one is the Geopolymer Alliance, that is participation from the industries, all the mining companies, and the scientific partners are all practically of the crème de la crème of the Australian universities and institutions. One member of this Geopolymer Alliance made a lot of buzz, a lot of noise on the internet. In June 2009, the CSIRO, this is the this is the institution that made the research on applied technology, published heaps. Fireproof coatings can really take the heat. So they published on the internet, they were the first to present a paint, a coating that resists high temperature. It is based on inorganic geopolymer resin and can be applied on practically any support. In fact, 2009, it was the public release of a research that they started in 2003. This is the patent that has been published in 2005. This is the name of the CSIRO. The title is Hybrid Inorganic Polymer Systems. Well, it is a jargon in terms of the abstract. It is MK750 based geopolymer with some amount of organic ingredients, organic molecules that allow them to have a good paint and to have something that is applicable. The inventors are Sagoe Kremzil. Those who are working with CSIRO are knowing him quite well. I met Quentzil in 1996 when he first visited us here in Saint-Quentin. And what I find interesting is that the second author is Wang from China. In terms of patents, there is a very important patent that has been published in 2008 and made a lot of noise. The applicant is Service Pétrolier Schlumberger. Schlumberger is the most important companies dealing with offshores, drilling, oil extraction. This is a well-known service company all over the world within the petroleum industry. The title of their patent, they had two patents: pumpable geopolymer formulation and application for carbon dioxide storage, We started to work with them in 2003. They came to our lab and asked them, is it possible to have a cement or something that can be pumped down to 2,000 meters where the temperature is around 100 degrees C and that it will not set during the path from the surface to 2,000 below, and then set, and it must be acid resistant, and it must be and so and so. For what purpose? For carbon dioxide storage, the storage that of carbon dioxide in the ancient oil whales or gas whale. So they worked with us in the lab, they returned back to their lab and they developed this type of cement. It is called evergreen system, CO2 resistant cement. Pardon. And they have started their application. So here what we have, end of 2009. So if you read it, the Evergreen cement was used to plug and abandon, of course, a natural gas producing well in a field where produced carbon dioxide is re-injected into saline water zones. New wells in the field are now planned to be completed using this novel cement that has been recognized for the benefits it brings to operations where the presence of CO2 requires a long-term solution, and so forth and so forth. The technology can be applied for both carbon capture and storage and for CO2 enhanced oil recovery projects. So it shows you that geopolymer is developed in what we call high-tech applications, even if it is cement, but these are very special cements. And this went through the internet and in fact generated a lot of interest. 2 years ago, 1 year ago, 1.5 years ago, one of the major research institutions, which is Institut Français du Pétrole in Paris, started research. There is a PhD working on that topic, trying to cope with what Schlumberger developed with us. And in the US, the US Department of Energy has asked two major research institutions, Brookhaven National Laboratory, that's in Long Island, New York, and Sandia National Laboratory, that's in Albuquerque, in New Mexico, to propose geopolymer sealing materials. And they have the money to do it. In France, we have other patents that have been filed in 2009 by another big institutions. This is the Commissariat à l'énergie atomique. This is the French Atomic Agency. Title, Method of Preparing a Controlled Porosity Geopolymer Resulting. They want to make porous geopolymer to control the porosity for catalytic purpose and for any kind of applications. Not for just insulation, thermal insulation, but for real industrial and precise applications. Here we have another application from another field. They also started with us in our lab and in fact extruded geopolymer frame profiles for windows or doors. This is something that could happen. It is more complicated. It requires good knowledge with the composite chemistry. We have it here another important one. This one is by Airbus. We are working with Airbus since 2007. Previously, we worked very strongly with, in the US from 1995 to 2000 with the Federal Aviation Administration. the fire department, target to have safe cabins that do not burn. However, it takes time for these aeronautic industry to take and to cope with these new materials. And in between, Airbus is looking at the geopolymer composite for very special applications. And here, these are aircraft conducts. These are special composites, like these ones. These are tubes, not this one, but similar to that have to transport fluids and gas from 400 degrees C to 700 degrees C. Another one, totally different, that I accepted with pleasure, is something that is also a very important application. This is in the work of art. Dr. Hanselschek will have a presentation tomorrow on that application. Yes, we are now. So you see, a lot of you are coming here because of geopolymer. You see, in the literature everywhere, geopolymer cement. When I started my research, I had no idea of cement. I am an organic polymer chemist. And until 10 years of my industrial life was polymer chemistry. I was well known in the textile, in linear polymer, in polyamides, polyurethanes, and so forth. And when I started in 1990, I will see it later. This is the history of geopolymer. This is the second part this afternoon. So I will not waste my time here now. So geopolymer cement is not geopolymer. Geopolymer is a concept, is the chemistry, the technology that is applied for making a cement and a concrete. You know the difference between a cement and a concrete. The cement is the binder, and the concrete the results from adding the cement to aggregates. Strange news happened in March 2010. This is the one in French. It says cement relocates to. Usually cement, you have the plants and 100 kilometers or 200 kilometers in radius where they are supplying it. The problem is connected with the CO2 emissions. The development of geopolymer cement is strongly dependent on the regulation of the CO2. If laws are enacted, if taxes are enacted, if something is happening on the burden of cement, you know, and we will come back during this session, that the cement industry is the major industry emitting carbon dioxide. The geopolymer cement is the ideal material. The problem is that the lobbying of the cement industry is so strong that in December 2008 in Brussels, the European Commission has decided to give a grace period for the cement industry until 2020, where they don't have to cope about CO2 emission. So we know that at least in Europe, nothing will happen in terms of geopolymer cement as a mass product until 2020, because the cement industry is not forced to pay CO2 taxes on the cement. But these people are clever. First, they work on geopolymer science. This I know, this because I worked with them. But they are more clever than that. They discovered the following. They don't care about the grace period, because this is what will happen, and this is the fact cement relocates too. And the article here describes the following. The cement technology, the cement industry has decided to manufacture the clinkers overseas, where it is free to produce any cement, any CO2 production, as long as it is allowed by the international laws, to ship everything by ship. This is relatively cheap. And then to have, at major terminals, grinders. The grinders in Europe, so that they will manufacture their cement in Europe with no CO2 emission. Yes?
It's the reason why clinker to import to Europe, you don't need reach. Clinker is taken as raw material.
Yes, okay, yes, yes. Yeah. Okay, so this is now the strategy of the Portland cement companies. So don't expect that, at least for Europe, the Portland Cement Company will help us to develop our geopolymer cement. They don't need it. The geopolymer cement are crucial for developing countries. They are not important for European countries. And I don't know what will happen in the US, but maybe they will do exactly the same. Nevertheless, geopolymer cement is propagated as being one of the best cement by the US Department of Transportation to make roads, and they published their first technical brief, tech brief on that subject. Nevertheless, in Australia they are far in advance, and in March the company Wagner's in Brisbane shows its first geopolymer concrete bridge made out of geopolymer concrete and composite. Nevertheless, in the US, always I'm talking of what happened on the internet. So those who are making noise. Louisiana Tech, so we have one representative of Louisiana Tech, this is Carlos Montes, who will present something about what they are doing, have presented their research using fly ash. And it is presented as being a green research. This is a word that I don't like. It is not green at all, and maybe it is dangerous. Why? We had, December 2009, in France, a publication by a newspaper of northern France that says fly ash is radioactive. We have in France, we practically do not have any coal power plants producing electricity because we have nuclear power plants. But in northern France, you see, we have a lot of tailings that are full of fly ash that date back to 30 years or 40 years. And one ecological organization started to measure the properties of these fly ashes, not only in terms of the amount of heavy metals, but also in the amount of radioactivity. And it is obvious, fly ash is an ultimate residue. So, which starts with geological materials that may contain more or less radioactive stuff. This is obvious. And depending on the amount, This is what you get. You get the fly ash that is 10 times more reactive than the coal. So some of the coal, of the clays, of the minerals that are constituting the coal ore contains more or less radioactive stuff. When you burn this coal, the remains contains more. This is obvious. So the consequence of that is fly ash-based geopolymer concrete would be recommended only for infrastructure, not for building and housing. And all these new startup companies that are making noise on the internet and are claimed to be companies who are making green concrete, geo-green concrete, ecological concrete, green stone, everything based on fly ash, may face problems with environmental lobbies. It's very light to destroy anything based on these rumors. Even if it is not true, something will be there. So fly ash for geopolymer cement, geopolymer concrete is okay for infrastructures, but don't do it for building and for homes, or you could have trouble. Because in fact, you don't need the fly ash. You have so many types of geopolymer possibilities due to geology. I have just some examples, and I gave the numbers of my chapters in the book where I relate to these geology. Metakaolin-based, slag-based, rock-based, we have several rocks, silica-based, soil-based, lateritic materials can be used, and you have a lot of mine tailings, not fly ashes, from the extractions of several mines that can be used very importantly in terms of geopolymer raw materials. Another paper made a lot of noise on the internet. It had been published by a well-known American magazine, Wired. I was informed by the fact that suddenly in our Geopolymer Institute we got more than 1,500 visitors per day because of this article. Super concrete in the US military, Iran, and the pyramids. So this is something that really addresses everybody. And I just put the introduction. The story of geopolymers is worthy of a Dan Brown novel. Dan Brown novel, this is a Da Vinci Code. With an unlikely cast, including a maverick French scientist, a secretive cast of ancient stonemasons, and the US Air Force Research Laboratory. Along the way, the mystery of the pyramids gets solved, but it might just end with American bombs bouncing off impervious bombers. So this paper was written in order to alert the Americans in general about first the development of geopolymers, which is very important, and second, first I forgot. For those who are not very familiar with the American language, maverick doesn't mean crazy, it means unorthodox and independent-minded person. And you understand who is this guy. So, the paper describes several things. First, it shows that the the US Air Force Research Laboratory is working on geopolymer application. They have two fields, totally different from one another. On one, high-tech application, it is for aircrafts. These are the composites, high temperature, and so forth. And on the other side, the low-tech is on cement, but for very special cement. It is to help the landing of their aircraft on the aircraft carrier. They have now a new aircraft that goes up horizontal, no longer this way, but vertically, and they have to protect the surface of their ship underneath, and this is now will be made out of geopolymer concrete because it withstands temperature. So these are the two major fields that is undertaken by the US Air Force Research Laboratory. Don't forget that geopolymer technology was used in the US between 1983 and 1995. This is where I worked on cement, where we invented the cement called pyramid, and the first application of the cement was for the US Air Force to repair the jetways during the night. The super bomber were in the air when the system was repaired. So it is not the first time that the US Air Force is working on geopolymer, but this is now officially claimed. What is the connection with Iran? Well, of course, in Iran we have several groups working on geopolymer cement and geopolymer concrete. I know some of them. And they said, well, there have been several patents filed by Iranian scientists. And they claim since the geopolymer concrete is so good in mechanical strength, could be twice or three times that of concrete, it could be possible that the Iranians will have their atomic installations under geopolymer concrete, and the American bombs will bounce on this geopolymer concrete. This is what is written in the paper. From what I know, from what they are doing, this is not, but we don't know. And then this is the connection with the pyramids, and this is a good introduction to the next topic, that is geopolymer and archaeology. So this went through the internet very strongly. This is the Massachusetts Institute of Technology, the famous MIT, a group of students under the direction of Professor Lynn Dober-Hobbs are making geopolymer stone for the pyramids, the way Davidovits is claiming. And this went through a lot of newspapers around the world, and this was an insult for the Egyptian government that responded this way. Zayawas, this is the famous man that you see in all documentary on Egypt. He is there. This is the head of the Egypt Supreme Council of Antiquity. Means no words in assailing the concrete idea. It's highly stupid. He said via a spokesman, the pyramids are made from solid rocks of quarry limestones. To suggest otherwise is idiotic and insulting. All my renowned scientific colleagues have been treated as being idiots, stupid guys by these idiots. So this is the situation in terms of why it is so hard to convince the Egyptian authorities about the feasibility of the pyramid theory. This is just a very brief list of those institutions that this have been a list in 2008. I'm no longer updating it. It is not necessary. This is just for the public that knows about the subject. To continue with archaeology, we now have our oldest geopolymer artifact ever made by mankind. 25,000 years old. It is the Venus of Dolny Vestonice. It is the first ceramic ever made by mankind. Before the Neolithic mine, this is Paleo-Neolithic. It is a so-called terracotta. And when I first saw this piece of artifact that is as big as this, I knew, we know how to do it. We have done such artifacts in our lab. And we have replicated it. It is a low temperature ceramic that is only feasible if you apply some of the geopolymer chemistry in it so we made it in the lab, made the shape, put it in to dry up in the garden fire, to dry up. First we have to go up to 200 degrees C to get the water out of the ceramic, otherwise it will burst. Then we'll put it in the fire in order to have the smoke, 400 degrees C maximum, and then we get the Venus. But to do this you need ingredients that are locally available. First, it must be a good clay. Second, you must have some of the sodium carbonate or potassium carbonates and so forth that are available in the plant's ashes, in the fire themselves. And we know that the ceramic, this Venus of Dolny Vestonice, contains ashes in it. So it is very easy, and it happens because it is easy to do. So for those who are testing long-term durability, they know this is official, at least 25,000 years. We also have our oldest geopolymer coating used for water cisterns, 4,500 years old. This is the first invention of what is called Roman cement, the opus signinum. This is the material that has been used intensively by the Roman engineers to make their aqueducts, the interior of the aqueducts, in order to make to seal, to make their cisterns, their baths, and so forth. And the opus signinum is a result of a reaction with lime and what they call in Latin testa, which is calcined metakaolin, which is metakaolin, plus other ingredients inside, some kind of zeolites. And this has been invented 1,500 years before the Roman time. And we know the inventor. This is the greatest scribe and scientist of ancient Egypt. It is Amenophis, son of Apu, lived 1537 to 1356 BC. This is his statue. This is one of the most renowned men in Egypt. He has been worshipped 1,500 years long and was deified during the Greek and Latin Roman period. We have some fresco depicting his career. This is this one, where we have his honorification, and we have here his name. This is Amenophis, and here his first title, the digger of cisterns and canals. The first system that we can recognize in Egypt is found in the famous Karnak necropolis close to the Valley of the King and the Valley of the Queen. This is where we have the village of the tomb workers. They don't have any wells. The water table is at 100 meters below. They have to carry their water from the Nile 2.5 kilometers away, and up to 1,200 people were living in these villages, and they were carrying the water every day. This water was put in the cistern, and they had their drinkable water available. This is the first system. The second system happened in Tel Amarna now. This is the city that was built by the pharaoh Akhenaten, the heretical, the monotheist, and here too. And then the third recognized system from the same time is in Urushalim, this is the modern Jerusalem, and this is what we call the first Solomon system, date back to that epoch. It is coated with a geopolymer cement. You'll find about the pyramids and this one in English and in French, the last that I published in 2009. This was my state of the art for 2010. I hope in 2011 we'll get as many or maybe more. And after the break, after the coffee break, it will be time for the individual presentation, and we'll start the real session of the Geopolymer Camp. Thank you for your attention.